Hey guys, I'm going to go over the practice example problems for 7.3 about inelastic and elastic collisions. As you saw in the video, the equations seem real bad, but it's actually not as bad as it seems. So let's look at the first one. Okay, so just like before, it helps to identify and label your numbers. So in this one, we have a blue 1,200 kilogram car going 42 meters per second slams into a stationary 2,000 kilogram red car. How fast is the red car going if the blue car is going 21 meters per second? Okay, so I've highlighted a lot of important information here, but first let's take a look at the equation we need. This problem does us the favor of actually telling us that it's a elastic collision. From what I've seen, there's a good chance they're going to be just like that. Okay, so the equation for elastic collisions, as we saw before, is m1 times v1 before plus m2 times v2 before is equal to m1 v1 after plus m2 v2 after. So let me clean this up right quickly. m2 v2. Okay, so this is the equation we need. Now, I'm going to fill in my variables here. So we have 1,200 kilogram car, that's the first one. So I've got 1,200 multiplied by the velocity before, that's going to be the 42 meters per second, plus our second mass. The second object is the red car. So the red car has a mass of 2,000 kilograms. So we've got 2,000 multiplied by the velocity of the second object before, and the red car, it says, is stationary. Stationary basically means it's not moving, so the velocity of the second object before is going to be 0. Okay, that's equal to, again, our mass of the first object, the blue car, which is 1,200, times the velocity of the blue car after, okay, which is going to be 21 plus the mass of the second object, which is the, where was it? Oh, the 2,000 kilogram red car. Okay, and what we're looking for is how fast is the red car going. So V2 afterward is going to be what we're looking for, so I'm going to make that the X. From here, we've got to do some simplifying. If we multiply these two, we get 50,400. 2,000 times 0 is 0, is equal to 12,000 times 21 is going to be 25,200 plus 2,000 times X. Okay, so from here, we're going to simplify even further. 50,400 plus 0 is going to be 50,400 is equal to 25,200 plus 2,000x. So remember guys, in these videos, I'm always showing as much work as possible, so just keep that in mind. So to get rid of the 25,200, I'm going to subtract 25,200 from both sides. So this goes away. And now I subtract it on the other side, minus 25,200. And that gives me on this side, 25,200 is equal to 2,000 times x. Okay, so from here, all we have left to do now is divide both sides by 2,000. So I divide by 2,000 on this side, getting rid of that guy. Divide the 25,000 200 by 2000, and that gives me my answer. Okay, so 25,200 divided by 2,000 is going to be 12.6 meters per second. Okay, so if you have a problem where it says it's an elastic collision, okay, that's the big key, elastic collision, we're going to use this equation right here. Make sure you write that down somewhere on your show your work answer sheet, so it'll be easy. It'll be right there, ready for you to use, and keep this video handy also, because all the problems that I set up are going to follow this model right here. So if you see problems talking about magnets, check out the other video, because I'll go over how to do inelastic collision problems in that. So thank you for watching, and remember, let me know if you have any questions.